What I kind of told some of you as I was walking around, what I would usually do is have, I go from left to right. The left term is the thing I want to convert. And I usually put this over 1. And then I probably, instead of putting quantity, 1 foot over 12 inches, quantity cubed, I probably, well, I probably would write this 3 times. So mine would look like, mine would look like 22.0 inches cubed times 1 foot over 12 inches, 1 foot over 12 inches, and 1 foot over 12 inches, all on a straight line. And the reason I would do that is I know I have 3 inches in the numerator, that's what inches raised to the 3rd power is basically, and I need them all 3 to cancel. And then I recognize I like this way because I see in my denominator I have 3 12 terms that I need to multiply by each other, or 12 times 12 times 12 in the denominator. In the numerator, I clearly see my units are feet raised to the 3rd power. Any questions about that? Okay, so we're going to kind of pick up there. Oh, goodness. We're going to do another one. And just so that we're all on the same page, I'm going to show you the strategy. But notice that we've got, it looks like we're going from the we're going from the English system, which is inches cubed, to the metric system, which is liters. Okay? If you ever have a problem like this, you actually, and you'll see on the next slide, I know you know the relationship between inches and centimeters? Yeah, you do. 1 inch is exactly equal to 2.5 centimeters. So you can go from inches cubed to centimeters cubed. Do you know the relationship between centimeters cubed and milliliters? They're exactly the same. And then do you know the relationship between milliliters to liters? Okay. Sometimes it's like, oh, sure, easy when someone shows you this. But we can go from inches cubed to centimeters cubed just basically using this relationship. I think of it 3 times. Okay? 1 inch is exactly equal to 2.54 centimeters. We're going to use that 3 times. You guys told me the relationship between centimeters cubed and milliliters is they're the same. So I went ahead and actually when I work a problem like this, I doodle. I actually write that in the margins or something. The relationship? Yep, I write the relationship in the margins. It's like my vine to get from point A to point B. And then the last thing, we do a lot of this in this class, going from milliliters to liters or liters to milliliters. So of course that's within the metric system. And you're in good company if you get the 1,000 in the wrong place, okay? But it's 1 liter is exactly equal to 1,000 milliliters. Okay? So I'm going to give you a few minutes. Go ahead on your whiteboard and see what you got. So the first term will be the thing I want to convert. It'll be the inches cubed on the previous slide. Right to where, yep. 25.0 inches cubed over 1. It's 2. But keep on here. Okay, because like 2.5 we have to keep that term too. Did you keep it? This is 2.5 cubed, cubed. So put the cube in there. So that's good. Yep.
Because it's a
This is inches cubed. And then this would be
so now just take 25 times this.
25 is about 225 cubes.
Okay.
And if you want to keep going, go ahead and put another term here. You can see that if you put, go ahead and put the next term. And if you change this, if you change these, let's see if you put them all. Let's put them again.
One more.
Yeah, and then in the top. Wait, well, I told you wrong, because that won't.
Oh, one
Yeah,
second.
yeah, I told you wrong. So you're close.
Wait.
Oh, we do stuff.
We already did.
Oh, there's
256.
what? Steve, you haven't, I don't know, we're gonna crack it again. I think you must have cubed something.
No, I cubed everything. I think it's 1,000.
I don't know, well, either way, girls. I got to watch. See, because you don't have to stuff written down. Because you write it, because you want to make a little picture. Like
You don't keep the first one?
yeah, you don't cube the first number. That's in the yeah, cube is just with the inches. Kate's got it. Yeah, still like it.
I've divided
So
this.
the map down,
So this number, where does it go?
there's no
Let's hang on to one more turn. So, and this, by the way, this would be so adding or sending what's going on? Yeah, do that. Oh, thank you.
I have a question. Get it, but I don't get what it is. First number. Don't get it.
20.
because you always have to look, you always need like 2,000, just keep that one inch, and you get that,
Right.
and then cancel each other out. You see like that,
That's cute.
see what I'm talking about, instead of cubing all this,
Yeah.
because it will cancel each other out, and change on that side of my understanding.
Cube this one.
Cute.
That's what I think, that one, this one has, it makes it
just inches.
Just
This is the value.
Yes.
This is the value that we should get.
It's
Never got it. I'm gonna
one.
explain the value.
you're gonna need the milliliters. I always thought it to, actually.
1 milliliter.
Yeah. Did you get the same thing?
That's what I want to say.
You got a headache, girl. Did you go to that?
And this
Oh, I didn't
this
go
is
for
five.
any
This
back.
is the last one. Okay, so we'll do it so like
I was gonna
first
say, I'm going
25,
tonight. If I have enough money, I'm
No,
going.
we
divide
sold.
by-
You might get why don't you keep the 22.54 cubes?
uh-huh.
Why don't we cube the 25 by 2?
Well,
Because, like I was talking to, Sarah, yeah. The inches cubed is the units that came up with 25 by 0. And we have to cube this because we know like flat, one dimension, 1 inch is equal to 2.5. And we're gonna have to cube that whole ratio.
And then it's 3/6, so you would want
Like it is
Right.
part
Right, the inches cubed is not part of the 25 by 0. It's just the units that.
So just keep it you don't, I seen it have to do the, you don't cube the first one because
and then
since we cube
it's
the second one, they
cubes,
cancel each other out.
cubes.
Inches to cube.
Inches cubed cancel each other out.
Yeah, how do you keep the
And
second one?
what's
There's no
the-
reason.
Yeah.
That's what makes sense to me, I guess, 25 divided by 6, keep 0.1. So you just.
What'd you say?
Add
The
that
rate
then
says
16 circles. It would be 0.
16, 4 times 34, 410.
And then divide that
They're gonna get you a calculator, Ilya. I'm gonna bring him
I
in
have,
next
I have.
time.
It's just-
He's using his phone.
by 0.
I agree.
That's just
I get it.
Because it's basic, from the previous one to.
Oh.
Okay,
That one was good.
so that's the answer, right?
I figured.
Yay, you win.
Yeah. I didn't know it was right. A few years.
So, you know, I thought I see people like taking pictures of like PowerPoints and stuff here and there. You could take pictures of your whiteboards because sometimes it's hard for you guys to get it in your notes and the whiteboard, so just take a picture of your whiteboard. I'm just saying. Okay, so there you go. Like I've been saying, I actually bumped up part 5 and 6, our one Alta homework, and it's now due Monday, because it was going to be due Thursday, which is just silly. So it's due Monday, which is, okay? I'm pretty sure, maybe someone can confirm this, if you don't get an Alta homework done on time, can you still do it and get credit?
Yes.
It's just late.
Yes, it's just,
And it's like a day later, so it's like a
Drops
points, it
some.
just drops a couple points.
okay. That was what I was hoping, okay.
I know because I haven't got my thing won't redeem.
Your thing won't redeem?
Yeah, every time I go to redeem it, it just stops. It loads forever,
Oh.
and then I have to stop.
I have Olivia back there, yeah. Did you do that too?
Went to go do the homework last night,
Uh-huh.
and all of a sudden it says my subscription was canceled. And I was like,
Did you put in a code yet?
I had to buy it.
Yeah, you-
I had to buy it.
Yeah,
I
did
had
you?
to buy it.
Oh, you bought it from them.
Yeah.
Okay, for both of those in Alta, they've got like a little screen in the lower right-hand corner that looks like a bubble. They will chat with you. I would chat with them and let me know if you have any snags, because that's not good, because you can't get into your homework. Maybe after, we can look at it together right quick. Well, I'm here then later this afternoon, so maybe you need to come by and see if we can knock something out. But that's not good. That's worse than my dog ate my homework. That's like also won't let me in to do my homework. Okay, so I know you guys handed in almost, we might be 100%. Hand in your lab homework or your lab write-ups. I'm not sure. If you didn't, don't feel bad because you still can. But I got a lot of lab write-ups up here. I'm excited. I'm gonna try to get them graded and back to you by Monday. We'll see. But anyway, in there you guys actually did a conversion that I'm going to talk about today. So anytime you have a physical constant, like density of something, the units of density you guys came up with, for your block, it was what, grams per centimeters cubed, units wise. And for your stopper, what was it? Grams per milliliter. So you had a number here, and you have the units. Anytime you have units for any kind of, I call that a physical constant of your object, you can use it as a conversion factor. So that's to say, you're going to see here on a slide, I can go back and forth between grams of a block and centimeters cubed of a block. I can go back and forth for the stopper between grams of the stopper and milliliters of the stopper. So the units, it's all about units, I'm telling you. So here we have methanol, and the density is given, and you're going to see on the next slide, I'm going to unpack that number because I told you anytime you see like a G/ml, you really need to fluff it up. What that really means, you're going to see on the next slide, is 0.792 grams per 1 milliliter. It's like a ratio. So we can work these two problems. That's not the problem yet, and actually consistent with what I've done with my conversions. My first term is going to be the thing I want to convert, and then I'm going to use the physical property, which is density. So the first question, my first term is going to be 242 milliliters. Then I'm going to use the density to my advantage to get units of milliliters to cancel, be left with grams. A lot of times when I'm working a problem, I don't really look at the numbers until I just don't look at the numbers. So we can do another type of problem here. In this case, we've got 50.0 grams. It's going to be my first term. I'm going to use 0.792 grams per mil as my advantage. So units of grams cancel, and I'm going to get units of milliliters. So I've mentioned unpacking or fluffing out. This actually is how you would fluff out the density. It says 0.792 G/ml. You can't use that like that. You have to say what it means. So we could say it means 0.792 grams per 1 milliliter for methanol. We could also say in 1 milliliter of methanol at that temperature, the mass would be 0.792 grams, or we could flatten it out. Let's say for methanol at that temperature, 0.792 grams is equal to 1 milliliter. Now, in all of these, and I think we've run up against this before, that 1 milliliter is kind of by our definition. There's no uncertainty in that one. There is uncertainty in that 0.792. Okay? So, if you want to, what you're going to do here in a minute on your whiteboards is pick one of these two ratios to get you down the road. So we're going to work those two problems on 2 slides ago. I went ahead and put the first term up there for you for the first problem. Don't break your whiteboards, guys. So 242 milliliters over 1 is your first term. You can use either one of those two ratios. It's all about the units. It's all about that base. Da, da, da. Nope. So over 1. Yep. And then use one of those two ratios on that previous slide. Very short slide. So your two ratios were are either or, not both. So they cancel each other out. You both don't. So I went ahead and put them on the. Here's your options. Yeah. Page. So if you get the first one, go ahead and go to the second line. 50 grams. 50.0 grams, 360.
Wait, so this is just 2 and then go on to the one. Yeah, we're going to Is that the question? Yeah. And so we have the fence. So that would be multiplied
This like this.
the other side and then we'll solve the everything up.
I think you're right.
Okay, then what's the next? 50.0 grams. Your number one is your first journal.
No, we're doing more.
See?
I just. Yeah, right, okay, I didn't, you're right, yeah, sorry.
This one, this is a multiple.
Oh. It was like-
So for your lab, remember what we did actually was the second one, right? It seems like so long ago. There were 3 ways to find the volume of your vial. And one of the ways that you did was by difference out the mass of water that your vial contained. And then you use the density of water at that temperature. I call it the flip version of the density of water. And that's how you went from grams to milliliters for your. I'm kind of serious about taking a picture of these if you want to, for your own, in case you need to refer to them. So, otherwise, I'm just gonna go on. Okay. I'm liking it. Maybe, go, no, yes. Oh. New battery, maybe. Okay. Now we have 2 more problems to do. Now this is a percent problem. 7.2% sucrose solution. In a minute you're going to see me unpack that. You cannot, in this class, just, I know it's tempting, but you can't go straight for the kill. You have to unpack it and use factor label. So we can work 2 problems. Anytime anytime you have a weight percent, if you look at the units, you know how you can use it to go back and forth. So weight percent, you guys are doing a lot of that for this lab that we did yesterday. That's the grams of the component divided by the grams of the whole solution or mixture. So this is how we can use weight percent to go back and forth between grams of the component and grams of the mixture. So we have those 2 problems here. In the first case, we're given, see how I kind of work problems like backwards almost? 65 grams. Now, I'm going to try to convince you of this, but you cannot just put 65 grams. You have to be, the word is explicit. You have to say 65 grams of solution. That's going to be my first term. And then I'm going to use my weight percent to get to grams of solute, which in this case is sucrose. The second problem, I'm going to put 3.1 grams of sucrose in the numerator over 1, and then use the weight percent of this solution to get to grams of solution. Yeah, grams of solution. So here's my unpacking. Here is my unpacking. So when someone tells you it's 7.2% by mass, this is what they mean. So these are, I don't know if you guys are, many of you are puzzlers out here, but it's almost like playing a jigsaw puzzle where these are our tools to get down the road. We're going to use these to our advantage. So 7.2% sucrose means 7.2 grams of sucrose for 100 grams of solution. It also means in 100 grams of solution, you have 7.2 grams of sucrose. One of my favorite is flattening it out. 7.2 grams of sucrose is equal to 100 grams of solution. And in all these cases, that 100 is, again, by definition, so it brings no uncertainty. If 100 brings no uncertainty, how many sig figs we got here? We have 2. We have 2 sig figs here. Okay, so here we go. This is my little slide to, and as you work this, hopefully you'll become more aware that you can't just leave it grams because you have grams of 2 things, grams of sucrose and grams of solution. So here we go. For the first one, it's going to be 65 grams of solution over 1. And then use the weight percent of sucrose to get you down the road. You want grams of solution to cancel. Grams of solution are in the numerator of the first term. So, can't use it as a ratio. I see that a lot, and actually there's a reason you can't use it as a ratio.
Okay, so that's 168, and she was in 278. There we go. Okay. I was like,
268, yeah. Oh. Yep, I see the whole ratio thing a lot, and actually this is where you could work all the problems and use ratios and definitely get the right answer. It's just that as problems become more difficult, the ratio ultimately will not, you'll not be able to click and put more answer. Just in general, take my word for it. So, factor label is your friend. I'm putting the second one up there now. See what you did. This is what I questions about that? Did you do the second one?
so that's 165 times.
The first one.
Turkey's done. Just kidding. Yeah, there's about, yeah, hopefully. Okay. All right, gonna do one more problem, and guess what? We're gonna combine those two, density and weight percent. So as you work this problem, you really need to make sure that as you unpack that weight percent for nitric acid, you clearly say, I think I have on my next slide, that 22.5 22.0% by mass HNO3 means I have 22.0 grams of HNO3 per 100 grams of solution. Okay. I'm also going to unpack the density. Now, the density is 1.13 grams of solution per 1 milliliter of solution. So anyway, to work this problem, I think of these as my puzzle pieces. What do you guys think is going to be my first term, how I usually work these? It's not in the first sentence. The way I work them, and some people work them totally backwards, but my first term will be the 75.0 grams of HNO3. What I do is I write that down as my first term. I probably will write, if I was doodling this, I probably would write question mark volume. So I probably would put question mark milliliters solution. That's what I'm trying to get to. And I'm going to start with what I tell you is 75.0 grams of HNO3 over 1. And then I'm going to have, I'll go ahead and tell you, you can get there with just 2 terms. We can use the weight percent, we can use the density. So here it is unpacking those 2. Okay, notice that, I guess the catch, sometimes I have a hard time convincing students, is when it comes to density, that is the grams of the whole solution over 1 milliliter of the solution. It's not grams of HNO3. It's grams of the whole solution, because how do you get density? You take the whole mixture, you take a little mass of it, you get the volume of it, you take a ratio. So those are my puzzle pieces. Those 2 things will appear here and here. They might be flipped, but they are going to get me down the road. Ready, set, go. First term, 75.0 grams of HNO3. So we use these 2 ratios to get to milliliters of solution. I dare you. I double. Your hint is the first term that comes next is the only term that has grams of HNO3 in it. 2 grams of HNO3. Cancel.
So, grams of 1 grams of solution. Yes. Okay. And this is
Yes, yes. Yay, I can see that.
So that's it. How do you do the consideration? You do multiply first.
Use your phone. You can do that. That's okay. Oh, okay. So I usually take this and this, and I divide it by this and this. It's like match game, I think, where they used to like, they had to write their answer and hold it up.
I have my answer. Is that on my board?
Okay.
So we'll have 5, 6, and oh wait, you're 5 and 6 different?
No, Monday.
Four was due.
So when we have, so we'll have 5 and 6 for Monday, and then 7.
Just, like, that's my only thing, is just, I don't think there is a, okay, so almost. I don't know why that is, but I don't think it's all percent.
Is that all?
Yay. What's that?
You said there's not also almost Thursday?
There's no work there's no chat, there's no park set. But no, there is homework due. Pretty much counted homework due Mondays and Thursdays. Just to make your Sundays and Wednesdays awful. Any questions about this?
I think what I'm most confused about is setting it up like once, like word problems and then like setting it up. Like once I get the numbers and everything, then I'm good.
That's why, yeah, it's the whole story problem thing. A lot of us growing up are still traumatized by working through
Yeah.
problems.
Yeah.